Oops, I forgot to give permission. Hang on a second. Okay, you should be good to go. All right, recording is started. Oh yeah, you can move me, or if you just minimize the cameras, it should make me disappear. But yeah, you can move me around. All right, inverse tan both sides, very nice. And we, of course, make sure that we are in radian mode. And then tan equals negative 30 degrees. And then if you're in, so that's if you're in degree mode, and then if you switch over to radian, I should have put in the directions, solve this, give me degree in radians. Sorry, I left that part out. So we got negative 30 degrees and negative pi over 6. So I chose this problem because this was the second to last problem on yesterday's lesson, and I had the wrong answer because I wrote it wrong. And some people probably left before we went over that. Someone called me out on it, and I forgot who it was. Dianica, it's probably you. Yep, it was. All right. Okay, so hopefully this unit hasn't been too bad so far. We've only had one quiz so far in Unit 2, which means everyone should be done with Unit 1. Part 1 and Part 2 of the test should be done from last unit. There's still quite a bit of you that haven't done your test yet, and it blows my mind. Makes me wonder why you're actually in this course, because you're not doing anything. Not because you don't belong here, but you're just not doing anything. So make my job a little easier and stay current, so I don't have to call you every day and ask you what's going on. All right, so this is 2.03 day number 2. We have 2 goals today. We're going to define angles of elevation and angles of depression. And we're also going to calculate the sides of special right triangles, in particular 45, 45, 90 triangles and 30, 60, 90 triangles, if my memory serves me right. All right, and we're being recorded, of course. Okay. Angle of elevation. Definition says the angle made with the horizontal and the line of sight looking up to an object or destination. So there is somebody standing here at A, and they are looking up to the top of the tree. This angle made with the ground, the horizontal, is called the angle of elevation. Pretty simple. I think you guys probably learned that in geometry, right? Maybe. Yeah. And then the angle of depression. So this one you got to be a little careful, just because you might think that the angle of depression would be this angle right here, but it is not. So the angle of depression is made with the horizontal and the line of sight looking down at an object or destination. So let me show you what that looks like on a picture, just like this. So the horizontal, this line here, horizontal with the ground, looking down from the top of the, a lighthouse? I think that's what it's called. This angle right here, angle X, is the angle of depression. And so so this is kind of asking we'll call it a bonus question with no bonus points. But kudos. How about, well, for kudos, when you have two horizontal lines and you have a slanted or a whatever you want to call this, a slant line that intersects both of them, what is this angle congruent with? Angle A. Yep. Does anybody recall what that? I don't know if it's not a postulate. Theorem. I haven't taught geometry in so long. Nobody understands what I'm saying, do they? Well, I'm going to tell you. It's alternate interior angles. Does that sound familiar? Yeah, so I think that's what that is. I think angle X and the angle A would be considered alternate interior angles. Somebody correct me if I am wrong. All right, well, we'll say I'm right. I don't know. I'm probably right. If I'm not, I don't know. Anyway. All right, so everyone, please answer this question. I'll read it out loud, even though my reading is not so good. And an officer on the flight deck of an aircraft carrier and sees one of the planes coming in for a landing. Planes have a typical landing altitude of 200 feet, and the angle of elevation that the officer can see is approximately 6 degrees. About how far away from the aircraft carrier is the plane? Round to the nearest foot. All right, so the first thing that you want to do is draw a picture. I think pictures make everything so much easier. If you want to do a little picture of a plane and maybe a picture of an aircraft carrier, knock yourself out. I'm going to show you my picture. This is the one that I drew. Yep, so there is that is actually a Lego aircraft carrier. It's my Lego aircraft carrier, and somebody standing on there is looking up at this. I believe that is a Fortnite plane coming in for a landing. And the word problem says that they are 200 feet above the ground, the horizontal. And they say that the angle of elevation is 6 degrees. So one mistake that people might make, the distance from the aircraft carrier. So it does say, how far away is the aircraft carrier from the plane? Well, that distance would be the hypotenuse, correct? And not one of the legs? Because that would be the horizontal distance, but the true distance would be the hypotenuse. So you got to think about what makes the most sense. So I could see some people missing this problem because they would put the side X, the side we're solving for, on the wrong side. So you really got to think about the problem, draw a picture, what makes sense. All right, everyone solve this. I'm going to give you all, let's say, 1 minute. That should be more enough time since I talked too long anyway. Speaking of the word anyway, one of my pet peeves is people that say anyways. Anyways is not a word. So people start talking blah, 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 and they say anyways, and then keep talking. Makes me cringe. Anyway is the correct word. Oh, Araceli. I'm going to minus 10 points. Anyway, everyone else keeps their points. All right, we got another 20 seconds to finish this problem up. You don't need scratch paper. You need notebook paper for math. Your notes is not, they're not scratch. It's not scratch paper, just so you know. All right, time is up. So here's a question. Did you all use sine, cosine, or tangent to set this up? All right, so I got a few people that say sine. Any other? Looks like everyone's doing sine. Okay, I think sine sounds pretty good. All right, what is the final answer rounded to the nearest foot? We got 1913. We got some more 1913s. I really hope I have 1913s underneath this box. Oh, I did. I did it good. All right, and then the setup, I'm just going to show it since it looks like a lot of you already have the answer. So the sine of the angle is equal to opposite, which is 200, over hypotenuse, which is x. Multiply both sides by x, divide both sides by sine 6. So there's a trick when you have fractions, and I do it a lot. I'm going to say it this time. I might say it another 2 times, but when you have like a fraction equals a fraction, you can actually trade places with diagonals. So x and sine 6 can trade places. So I do that trick a lot when I'm working with fractions. Mathematically, what you're doing is you're, in this case, dividing by sine 6 and multiplying by x, both sides. But again, the trick is when you have a fraction equals a fraction, you can actually take diagonals that are on opposite sides of the equal sign, of course, and they can trade places. Does anybody here do that trick? It's a good trick. Never heard of it. Well, you've heard about it now. It's a very valuable trick in math. Okay, if it confuses you, just do the math way. And in this case, divide both sides by sine 6 and multiply both sides by x. That's what I did. As long as you understand the math portion, you're golden. Yeah, you're just skipping steps. But I do that trick a lot, especially here on out when we deal with a lot of fractions. I'm going to do that trick quite a bit. And I think your Learn modules do the same thing. But you know, those things are notorious for skipping quite a few steps. All right, so yeah, so all of you should have typed in 200 divided by sine 6, and you should be in degrees because this is obviously degrees. So it's important to know if your calculator is in degree or radian mode. So if you're in radian mode, I don't know if it even works. Yeah, it should, I think. Maybe. I don't know. But you'll get a totally different answer. All right. Any questions on this problem? Pretty simple. So when you work out the examples in the Learn module and Practice module, practice drawing pictures, writing out the work, and doing them and typing them in. You know, if you just read the example problems, but you don't actually type them in, how do you know if you even know how to type them in? You know, a good way to fail this exam is if you actually never practice typing stuff in, then when you actually take the test, and you type stuff in for the first time, and then every time you type something in, it's wrong. And that's on you. Just saying. All right. Anyway, let's keep going. Special right triangles. So we are on to goal number 2. All right. So, and I'm pretty sure, because I remember when I taught geometry, you should have learned these 2 triangles, the 45, 45, 90 and 30, 60, 90. They look super familiar, I hope. Yeah, so I think no matter what school you went to, and doesn't matter what state, this is something that's pretty universal, I think. All right, so let's go do the first one. All right, the 45, 45, 90. So this is just kind of telling you in words what to do mathematically. So the legs being coming off the 90-degree angle, these are both the same, variable n and n. To go from the leg to the hypotenuse, you multiply it by radical 2. Pretty simple. If in this triangle you are given the hypotenuse, to go from that to the leg, we divide by radical 2. So from here to one of the legs, you take whatever number is here, divide by radical 2, and that will give you this side. I think 45, 45, 90 are probably the easiest ones. That's why we're doing it first. All right, so let's look at number 5. 45. And just to ask you a very simple question, all 3 angles of a triangle add up to what? 180 degrees. So we got 90 plus 45 plus, well, 45, right? So 180 minus 90 minus 45 gives us the missing angle, which is 45. I just want to make sure that's clear. All right, so number 5. Do I have a volunteer for number 5? All right, Julia, number 5. Go ahead and write it out for us. So yeah, we will do number 5 first. But yeah, you can do number 8, Emily, when we get there. If you'd like to explain in words what you're doing or what you did after you write it, feel free to. All right, looks good. So looks like the legs are the same. So if that's 3, that has to be 3. And then to go from the leg to the hypotenuse, you just take that leg value, multiply by, well, radical 2. All right, number 6. I'll give you all 30 seconds to do number 6. All right, class, go ahead and chat. What did you get for this side right here? Two radical 2. 2 radical 2. Some people got 2. Maybe that was a typo. But yeah, it is 2 radical 2. So let me go ahead and grab my pen tool. And write in. Whoa, my pen's freaking out. Make sure nothing's touching my screen. Let's try that again. Okay, apparently I can't write today. Okay, yeah, I don't know. Looks like I'm not writing today, guys. I don't know what's wrong with it.
I can't delete it either.
Thank you. All right, 2 radical 2. All right. And then the other side. Go ahead and chat. Go ahead and write down what number goes here. I'm going to give you all a hint. Nobody got it right who wrote in chat. Come on, people, be brave. Me neither, Emily. Haven't seen a right answer yet. Oh, wait, hold on. All right. Just kidding. Good job, guys, who wrote 4 in chat. Good job. I'm not even going to tell you what I was thinking about that problem, because I was not thinking about that problem. Yes, this side is in fact 4. And somebody on mic explain why it's 4.
It's because square root of 2 times square root of 2 is 2, and then multiply it by the coefficient, which is 2 again, and you get 4.
Perfect. Yes. 2 radical 2 times radical 2. Well, was that you, Emily? Who was talking? Okay, it was. Okay. Yes. So radical 2 times radical 2, like Emily said, is equal to 2. And then 2 times the coefficient of the original, the 2 radical 2, is 4. So nice job. It is 4. I'll have to use my mouse to write a 4. Make sure I can write a mouse. Yep. Okay. I want to make sure I can at least draw with my mouse. I don't know why my touch screen is freaking out. I don't know. I do not know. Let me unplug my touchscreen and plug it back in. Give me a second. Okay, looks like it's working now.
We had a question in chat asking if you could please explain the last 2 problems one more time.
The last 2, like number 5 and number 6?
Correct.
Okay. So the 45, 45, 90, going from a leg to the hypotenuse, you take the leg value and multiply it by radical 2. To go from the hypotenuse to the leg, we divide by radical 2. So looking at number 5, the legs are the same, 3 and 3, and then going from leg to hypotenuse, 3 times radical 2 is 3 radical 2. Number 6, legs are the same. That's why it's 2 radical 2, 2 radical 2. To go from the leg to the hypotenuse, again, we multiply it by radical 2. 2 radical 2 times radical 2 is 4. To write down that math, how we got 4 by hand, which you guys should be just typing this stuff in, but 2 radical 2 times radical 2, well, if you remember your rules about multiplying radicals, what's underneath gets multiplied together, and 2 times 2 gives us 4. The square root of 4 is 2. And then 2 times that coefficient gives us 4. So that's how you do it by hand, but you should be typing this stuff in. Good. All right. So everyone go ahead and do number 7. And you guys should actually have probably 7 and 8 done by now. So what is the sides, both legs? 2 radical 2. Nice job. Wait, hold on. You said 2 radical 2? So make sure you rationalize it. Yeah, make sure you rationalize it. So going from the hypotenuse to the leg, we divide by radical 2, correct? But you can never leave answers with a radical in the denominator. It's not allowed. So maybe you have an FX 115 or a 300 and you type it in and it'll do it for you, or you do it by hand. So how do I rationalize this? Yep, Caitlin is correct. Multiply top and bottom by radical 2. Yep. So we can't square both sides because that's changing. Yeah, you can't do that. Doesn't work that way. So we have to, I'll use different color. Let's use this color. We're going to multiply top and bottom by square root of 2. All right. So numerator, 2 times radical 2 is just 2 radical 2. And then on the bottom, square root of 2 times square root of 2 is square root of 4. And the square root of 4 gives us 2. Everyone good so far? And then we have to reduce or simplify, and the 2's cancel out, so we're left with radical 2. So that means that this side is radical 2, and so is this side. It is very important that all of you in this class know how to rationalize denominators, because we're going to do it quite a bit from really this unit and on. And going forward, I may not show these steps. And the last thing I want for someone to do is ask me how I did that, because all of you should know. So going forward in these units, I'm gonna probably show less and less steps of stuff that all of you should know, this being one of them. Now, I might doodle some work, but I probably won't go in detail of why I did it. All right, so we're good on this problem? All right. All right, everyone do number 8. And it looks like this problem is actually much easier than number 7. So what are the lengths of both sides? 7. Yes. Yep. So we're just dividing by radical 2, both to 7 radical 2, and that gives us just 7. Yep. Okay, so that little refresher on this 45, 45, 90 triangle is good. Thinking way back to geometry. All right, now let's go on. I'm going to skip. I have these examples. Let's tell you what. I'm going to use one or both of them for bell work. Or if we have time in the class, we can come back to them. We're making pretty good time, but I'm going to skip these. Is that okay? I'm going to skip these too. Looks like I have Lots of examples. 1, 2, 3, 4. So I would recommend maybe doing these problems on your own, and then tomorrow we can go over the answers. Well, that looks the same. 7 looks like the same. We just did that one. Yeah, we did. Oh, they are the same problems. I forgot I spread them out to have more room to do the work. I'm so funny sometimes. Yeah, no, these are the same problems. Okay, that explains it. I'm smart. You and me both. You and me both. Yikes. Algebra 1. That's going to be easy. Okay, the other special right triangle are the 30, 60, 90 triangles. All right, so the leg coming off the 60 degrees. Now, make sure you are focused right now. Everyone, if you're dozing off or eating your cereal or whatever, the leg coming off your 60 degrees, that is your side in. So we're going to pretty much base everything off of this side. So going from this side coming off the 60 degrees to the hypotenuse, you multiply this side by 2. Again, going from this leg to the hypotenuse, multiplied by 2. Going from this side to your other side, which comes off the 30 degrees, you are multiplying by radical 3. Again, here to here, multiplied by 2. From here to here, multiplied by radical 3. Going from this leg to this leg, you divide by radical 3. Going from the hypotenuse to this leg, you are dividing by 2. So you always want to go from hypotenuse to this leg or vice versa, this leg to this leg or vice versa. You really probably don't want to go from this side to the hypotenuse, just because you have to do 2 things: divide by radical 3 and multiply by 2. So you really want to avoid this side to this side, if that makes sense. Yeah, so if you know one side, you know all 3, just like the 45, 45, 90. Your point of reference, the side should be coming off at 60 degrees. That's the important piece, so you don't mix things up. So let's look at, we got 9, 10, 11, 12. Okay, let's have room. So I'm a fast learner. These 4 problems, well, the first 2 are here, and then the last 2 are here. Let's not make that mistake again. Alrighty, so there's your 60 degrees. So what does that tell you about the 5? Yep, that's your n. So to go from this side, let's go to the hypotenuse first. What do I do? Multiply by 2. Very good. So what is 2 times 5? Yeah, 2 times 5 is definitely 10. So let's go ahead and put a 10 here. Yep. All right. And then let's go back to the 5, which is the n. So going from this side to the other side, what do I do? Multiply by radical 3. Yep. So that means, what should I write there? Not a trick question. 5 radical 3, yeah. Notice I like saying radical instead of square root, even though same number of syllables. 5 radical 3. All right. So number 9, are we good on that? All right. Let me give you all let's say a minute. Should be more than enough to do number 10. I'll tell you what, I'll give you 60 seconds instead. Ready, go. We got a whole 10 seconds left. All right. We have a volunteer to write the answer down for number 10 for us. Antonio, is that an I or a 1? I don't know. It's I. Yeah, Antonio, go for it. So does everyone agree with his answers? All right. Yep. Let's go ahead and just talk about it briefly. So it looks like this would be your N side because it's coming off the 60. So going from this side to this side, we have to divide by radical 3. Okay, so yeah, 8 radical 3 divided by radical 3 is 8. And then going from this side, which is the N from the formula, to the hypotenuse is you multiply by 2. So 8 times 2 is 16. Very, very well done. All right, let's see the last 2 problems. All right, let's give you guys, we'll say 3 minutes just for fun. If you didn't hear me, 3 minutes. Oh, wait, that's not 3 minutes. I wish I could see. 3 minutes. Here we go. 3 minutes. So you guys want to hear a fun fact, a fun theoretical fact? So I took, when I was in college, I took a bunch of physics courses, and one of them, my last one, was it was a theoretical physics class, and talking about kind of like speed of light, a lot of stuff like that. And as you approach the speed of light, time slows down for that person. So as the person approaches the speed of light, time slows down. So that means somebody who is not going at speed of light, who is observing this person, after they stop moving the speed of light, that person is actually younger than they should be. And the person on Earth who wasn't moving the speed of light would be older to the person who left to travel. Neat stuff. Yeah, speed of light. Crazy stuff. Then there's also with, like, as you move faster, objects change size. But anyway. You know, it made my head hurt then too. All right, I got another 49 seconds left. Oh, I know lots of dumb facts. Nothing that'll help you in life, but they're interesting. Victoria, you are correct. That's what I call myself too. All right. Volunteer number 11. All right, Emily, you can do number 11 again. How about number 12? Number 12. Preferably somebody new. Okay. Katie, you haven't gone today. So, yeah, go ahead, Katie. Yeah, 11 looks good. Another volunteer for number 12. Number 11 still there. Isn't number 11 off, though? So let's look at number 11 before we do 12. So looks like the given side is the hypotenuse, which is 6 radical 3. So go from the hypotenuse to the 60 side. We have to do what? Divide by 2. So 6 radical 3 divided by 2 is what? It is 3 radical 3. Yes, you are correct. So again, we have the hypotenuse side. To go from the hypotenuse to the 60-degree side, we have to divide by 2. So there's a 60 degrees. So hypotenuse to this side, you have to divide by 2. All right. Everyone agree with that answer so far? I can, yeah. Let's finish number 11 first. No, it's okay. It's okay. So some of you might need a little bit more time when you're first learning this stuff. And, you know, doing problems on the spot isn't easy. There's that anxiety factor that's in there of getting stuff done quickly, right? So I don't blame you. Yeah, when I was in high school, way back before any of you were born, my chemistry teacher called me a career test taker. Why? Because I was always the last one to finish the exam, like the very last. So nobody here should feel bad about taking extra time to finish problems. People work at different rates. It doesn't mean you're just because you can finish a problem really fast doesn't make you smarter. All right, so we now have the 60-degree side. So going from this side to the other leg, what do I do? Three radical 3 times radical 3. Yep. So you're taking whatever number that is and you are multiplying by radical 3. And 3 radical 3 times radical 3 is equal to 9. You can go ahead on your own paper, write it out, or type it in your calculator and you'll get 9. I promise you. All right. Are we good in number 11? All right. Number 12. Let's take a look at that one. So looks like we have this, and to go from the one coming off the 30-degree side to this one, we have to divide by what? So we're going from, remember, this is 30 degrees, so that puts us on this side. So going from this leg to this leg, what do? We divide by radical 3. Yep. So I'm going to go ahead and just write that below. So we are dividing by square root 3. And then we have to rationalize. So everyone quickly do that if you haven't done that yet. So we should get 8 radical 3 over 3. Yep, that looks right. I'm gonna go ahead and finish that work. Let's see. So multiply top and bottom by square root of 3. And we get 8 square root 3 over 3. So this side is, let me use an actual pen. This side is actually 8 square root 3 over 3. All right, are we good on that side? Any questions on how we got that? Okay, and then going from that side, because it's almost always easiest to go from the side of 60 degrees and going to the hypotenuse and going to the other leg. So going from this side to the hypotenuse, what do? Multiply by 2. Yep. So what should the answer be for that side then? (16 radical 3 divided by 3). Yes. In chat, go ahead and give me a yes if you got that one correct before we went over it. I'm just really curious. It's okay if you didn't. That's why we went through it. And I thank you volunteers who attempted these. I don't think that's true, Sarah. I don't know. You probably know more than you think. So if it helps to label your sides, like this would be n, this would be 2n, and this would be n. Oh wait, hold on. I messed that up. I'm thinking of the other problem. Let me start over. So the 60-degree side is your n. This is going to be n radical 3. And then the hypotenuse is going to be 2n. If it helps to label your triangle like that before messing with the numbers, please do. It might make it much easier to look at. Yeah, so label the sides. It'll make things much easier. You'll probably make less mistakes or no mistakes. All right, that was our last example. So we have any other questions before we stop this? Nope. Well, guys, thanks for coming. As always, I hope you learned something.